Okay, hello everyone. Back recording another data analysis video. This is going to be a short one, hopefully, but very short. So I've just recorded a series of, I think, 10 videos showing how to create certain figures and plots using the matplotlib software library and the seaborn software library in Python. What I thought I would do is make a quick video showing you how to sort of export and save those plots and figures that you might have created. So I'm working in Jupyter Notebook still, and usually, we run our analysis in the notebook. We create our figures, whatever data visualization we're interested in doing. But sometimes, if we want to use those particular figures for publication of some sort, we're gonna want to export the figure as a separate file, as either a PNG file, a tiff file, a PDF, something like that. And what I'll do here is demonstrate how to, just with a couple of examples, how to export and save some sort of figure, some sort of plot, using both matplotlib and the seaborn library. So I'm going to start as normal. I'm going to start by importing libraries that I am going to use. I'm going to import pandas as PD, numpy as NP. Probably don't need numpy, but I'll import it anyway in case I do choose to use it for something. I'm going to import matplotlib.pyplot as PLT and seaborn as SNS. So the usual. Hopefully by now you're familiar with those nicknames, and that's the conventions by which they're used and referred to. I'm going to import some data that is kind of available online, open source. It's a number of people have it available on GitHub repositories and things like that, and it's called I've got a copy of it saved on my computer, gasprices.csv. So it's data about essentially in what in the UK we would call petrol prices by countries over a series of years. I'm not sure where it originated, who originally collected the data. It's probably available on some kind of open source machine learning repository where there are lots of, such as the one at University of California, where they have a large machine learning repository, lots of data sets available on it. But I'm just going to use it to kind of create a real simple plot and then save that as some type of PNG figure. Okay, so I've used the pandas.readcsv method to import that data for a data set. gas_prices.csv is what it's saved on my laptop as, and I've just called header, and you can see basically we got a list of countries. One of the variables is the year, and it's got prices of fuel, of petrol, for those countries. And all I'm going to do here is I'm not going to explain this too much because I've demonstrated this in other videos. I'm going to use matplotlib to create a figure. I'm going to give it a title: gas price changes by year in US dollars. I'm just going to plot the price of petrol in the UK and the price of petrol in Canada, just as line plots essentially. I've put this plt.xticks argument just to sort of tidy up the x-axis scale. A legend as well, so we'll be able to see which country, which line relates to based on the colour. But the key thing here is this argument I've put here, plt.savefig, and then within parentheses I've given as a string object within single quotes the name of the file. So I'm calling this I'm going to create this plot and at the same time save it, export it and save it as a PNG file, so like a photographic image essentially. petrol_fig.png is what I'm calling it, and I've specified that also this DPI argument, dots per inch, as 300. So usually if you're publishing in scientific journals or something like that, you have to have reasonably high resolution images, figures, and 300 is fairly high resolution. So I've set that to 300, and if I run this, we'll see what the figure looks like. It's just a really simple line plot. There we go. It's got a title, it's got 2 lines plotted on it. You can see that the price of petrol is much higher in the UK every year no one would be surprised by that who comes from the UK compared to Canada. But I plotted various other things on there, but the key thing that I wanted to illustrate was having execute that particular cell, it has also saved this as a PNG file. If I bring up the file on my computer where this is saved, so I saved it and then I scroll down to, I saved it as petrol fig, I believe. There we go. You can see it's there, petrol_fig.png. It's saved as a PNG file. If I open it, it doesn't look too great because the figure is very nice, but I've got this background. The software I'm opening this with, it's got like a black background, so you can't see the scale, the year, on the X and Y axis, and you can't read the title that well. But against a different background, you'll be able to see those things. So you can see that's worked there, saving a PNG file. So you can change this extension name to save as different things, and I'll kind of illustrate that now. I'll demonstrate that using seaborn. So if you've created a plot in seaborn, you can save it the same sort of way, and you save it using the matplotlib save fig command, essentially. And remember, as I've said previously, seaborn is built on the base of matplotlib. So what I'll do is I'll just create a quick plot using, I'm going to import the Titanic data set that I've used in another video as an example, and I'm just going to create a categorical variable for class. I'm not going to talk through too much about what I'm doing there. I've demonstrated in other videos. And all I'm going to do is create a violin plot with the class, whether they were a first, second, or third class passenger, and the age of the passenger on the y-axis. But at the same time, I'm going to call the plt.savefig method, and I'm going to save. So I'm going to save this as a PNG as well. So I've called this Titanic_fig PNG. So if I run that, see we get this violin plot. And if I bring up my folder where this is all saved, you can see there we've got this Titanic_fig.png. So the PNG file has been saved in that folder. It's been exported, and this figure has been saved. Let's look at a couple of others. So often when you publish stuff, if you're kind of publishing some sort of research article, something like that, they'll either want high resolution PDFs or TIFF files. So to get those it's quite straightforward, quite simple. I'm going to create the exact same violin plot as above. I'm calling the plt.savefig method, and I'm going to save this as a PDF, this one. So all I've done here is I've kind of changed the name of the figure, so it's not the same as the one above, but I've changed that extension to PDF from PNG, and I'm also going to add this dots per inch DPI argument, set that to 300. So if I run that, we get the same image, but the main thing we're interested in is, there we go, it's saved as a PDF file on my computer. There we go, a nice high quality, high resolution image that has been exported. Okay, so I'll just demonstrate one more using the TIFF file. So I'm going to exact same image as above, and you can see this time I've changed the name of the, I'm saving it as Titan_tiff_fig.tiff. So I've just changed that extension to .tiff. So it's going to save it as a TIFF file, kind of a similar sort of file to a photographic image, something like that. So I've done that. Let's have a look in the folder there, and there it is. It's saved as a TIFF image. So yeah, and that looks really nice, and I think I've opened that with possibly with Paint, and that just Windows Photo Viewer there. Okay, so that's all I was going to demonstrate in this video. So having previously created loads of videos showing you how to generate these sorts of plots, sometimes it can be useful to export and save them if you need them for presentations, for publications, such things. Okay, hopefully that was a useful video.